Hello and welcome to this video on understanding relations. Now, I'll preface the video by saying that this is geared more toward an intermediate algebra or beginning algebra student. If you are looking for a more in-depth talk about the concept of a relation between two sets, in maybe the discrete math sense, do you search elsewhere for a video on that. I might put out a video like that in the future, but for right now this is geared more toward beginning and intermediate algebra students. And I'm just going to go over a couple examples that I've actually just pulled from an intermediate algebra book textbook. Alright, so again, I'm going to go over a couple examples and talk about what a relation is. Right, a relation is simply a correspondence between two sets, right? Two sets of elements. They don't have to be numbers, as we'll see in my first example. And yeah, so let's get started. So I have here, use the map. This little drawing here with the boxes and the arrows from elements in one box to elements in another box. That's a map or a mapping. So use the map to represent the relation as a set of ordered pairs. Alright, so first off, as I mentioned, we're going to talk about a little bit what a relation is. Right? So first off, a relation in mathematics is a correspondence between two sets. It's really just short for relationship. The elements in this collection here, the elements in this set, have some sort of relationship to the elements of this set in this box over here. Alright, so a relation is a correspondence I believe it's a correspondence. I should have looked that up. Correspondence, my apologies, relationship between two sets. Alright. So what I have here is a relationship between, a group of friends. And let's just say these are a group of my friends, just names of people I know. And to this, a correspondence or relationship between this group of friends and this group of dates, which are birthdays of these people. Just a group of dates. So I have a set of names of people and a set of dates of the year, and there's some sort of relationship between them, a correspondence between them. So this is simply a relation from the set of friends onto the set of birthdays. And some notation you'll come across. So suppose I have two elements, say x and y, belong to these sets. That I'm talking about, the two sets here. Some notation you might come across is that, maybe x arrow y. This element in one of the sets corresponds to this element in the other set, kind of like I've got the arrows in my mapping up here. Again, this is called a map or a mapping. Alright, this picture. Yeah, so if I wrote this out, x arrow y, or another way to indicate that an element from one set corresponds to an element in the other set, is to write it as an ordered pair, which is what I'm asked to do in this example. Right? So you write it as a set of ordered pairs. So x comma y in parentheses like this. These mean the same thing. this x arrow y, x comma y ordered pair just simply mean that x corresponds to y. Or y depends on x. This value of y depends on this, this value of x. It comes from it. You start here and would go to y. There's that relationship. And then one other thing I'm going to point out before I actually go into what they want me to do up here is the ways we're going to represent a relation. All right, so the representations of a relation. That we're going to come across in this video and some future videos. I'm not going to do all of these in this video, just got a couple examples. But one of them is a mapping, or just a map. Darken this in here. Yeah, this marker is getting pretty faint. Into the trash. Alright. So a mapping is exactly like I have up here. I mentioned this. That's where you have the one set, one collection of objects in a little box on one side of the picture. The other collection, the other set that it relates to, that it corresponds to, has a relation with in the other side of the picture. And then just little arrows indicating what elements of one set have a relationship to what elements of the other set. Another representation, which I'll get to in a second, is just as a set of ordered pairs. Okay, and the ordered pairs will look like, this, where you have an element, and if I see an ordered pair in my set, that means that this element's from the first set, and it corresponds to this element from the other set in the relation. We'll get to that in a second. And then the ones we aren't going to really be looking at today in this video, but in future videos, and one way to represent a relation is with an equation. Now this is typically reserved for when it's a relationship between two sets of numbers. Say y equals 2x plus 1. There's a relationship between numbers representing x and numbers representing y, those two sets. But yeah, this is typically used to reserve for representing relations between sets of numbers. Because if I asked you up here, could you write me an equation that, took Alicia to January 20th? I don't understand. I don't know how you could plug in Alicia and get out January 20th. It would be a really interesting equation to write there. I don't know how you could really represent that. I'm sure there's a way you could, but I'm not going to be creative enough to do that just now. And then lastly, these are the main four representations here. I'm sure there are others, but we're not going to come across too many of them in my videos here, my talks here, in this intermediate algebra stuff. So after, and then if you have an equation for a relationship between two variables, between two sets of numbers, then it's reasonable to say you could also make a graph of the relationship, draw a picture of it, whether show on the coordinate plane with a horizontal axis, vertical axis. Every ordered pair represents a point on it, and draw a picture representing this relationship between the set of two two sets of numbers. Okay. So the ones we're focusing on today are just a mapping and set of ordered pairs, and I'll get into later when we have just relationships between sets of numbers, writing equations for them, and also producing a graph, a picture. Right. So finally, back to this example. So I'm going to use the map. to represent the relation, this relationship, this relation from the set of friends to the set of birthdays as a set of ordered pairs. Okay, so here we go. So I'm creating a set, right? So if I'm creating a set, I'll start off with the little curly brackets again, just making a little mini S shape and then do it backwards. Right? And then I'm having a set of ordered pairs, whereas I mentioned over here, if I have an ordered pair in my relation, the first element comes from the first set, and the second element will be the one on the other end of the arrow in the second set, in the set of birthdays. So I'll have friends, comma, friend's name, comma, birthday. And there's only going to be an ordered pair if that friend has that birthday. So I wouldn't have an ordered pair of Max with January 20th, right? Because Max has the birthday November 8th. So I'm going to put that ordered pair in here. So in parentheses, the first element, the value from the first set, Max, comma. And then what does Max in this set correspond to? In this set, it's the date November 8th. So I've got this ordered pair, Max, comma, November 8th. Great, that is an arrow in this, there is a relationship, a correspondence between these two elements. And as I said, you wouldn't have Max January 20th because there's no relationship there. That is not Max's birthday. All right, so don't just make any ordered pair you want. Right? You have to make ordered pairs. The ordered pairs have to mean something. They have to actually demonstrate a relationship between values in these sets. Okay, so there's one ordered pair. Another ordered pair in this set, I have Alicia. Again, corresponds to January 20th. So Alicia, parentheses, Alicia from the first set, comma, January 20th from the second set. And there's another ordered pair. All right. Then we have another ordered pair after the comma here. Trent from the first set corresponds to March 3rd. Trent, comma, March 3rd. Sorry about the clutter here. And another ordered pair belong to this set. Yolanda would correspond to also November 8th. And let's see, we have another ordered pair with Wanda in the first set. The friends corresponds to July 6th in this set of birthdays. So we have Wanda, ordered pair Wanda, comma, July 6th. And we have one last ordered pair here. Elvis from the first set corresponds to January 8th from the second set. So Elvis, I have the ordered pair Elvis, comma, January 8th. And that's it, right? Those are all the relationships between elements in this set of friends and elements in this set of birthdays. So I've completed the set, and then I'll close with the curly braces. And just for the other one, a little backwards S and then a regular S. Practice those. Impress your professor. And then there we have it. Right? That's all I was asked for. What I put in the little box here. These represent the same relationships, right? This picture, this mapping with the arrows, and this set with the ordered pairs mean the same thing. They represent the same relationships between this set of friends and this set of birthdays. So hopefully that would be an easy transition for you. If you're given a picture like this, a mapping, could you do this? And hopefully it's very easy. Just look at the arrows, look at the relationships that are actually there between the sets that are given. Great. And then the only other example I have for you, pretty simple again, is just going the other way around. If I was given a relationship between two sets as a set of ordered pairs, represented this way, could I draw a little mapping? And I think it's pretty easy. Now here I have, just sets of numbers this time. So in this example, I'm asked to use the set of ordered pairs to represent the relation as a map. Okay, so when I'm seeing these ordered pairs here, this means, 1 belongs to the first set that I'm looking at, 3 belongs to the other set that I'm looking at in the relation, and 1 corresponds to 3 because they're in this ordered pair, or 3 depends on 1 if you want to say that. And then 5 in the first set corresponds to 4 in the second set, 8 in the first set corresponds to 4 in the second set, 10 in the first set corresponds to 13 in the second set. Alright, and so if I want to make a map, right, this is a set of ordered pairs, one representation of the relation. I'm asked to make a map or a mapping. Sometimes it's also referred to, you might see in other texts, referred to as an arrow diagram for obvious reasons, right? Because I had the arrows, and look at that, the arrows pointing from the element in one set to its corresponding element in the other set. Okay, so let's do this. So the first set, I'll put a little box over here, and then we'll have the elements from that set. Now there's 1, 5, all the first coordinates of these ordered pairs, right? 1 belongs in there. I like to put little dots next to it like that. That represents the element 1. 5 is in there, right? From the second order pair. 8 is in there, and 10 is also in there, and that looks like about it, right? Those are all the first elements, the first coordinates of my ordered pairs. Okay, so here's the first set of numbers, and you'll see, and I'll do more examples of this in a future video, but this first set of numbers here, this set of first elements, first coordinates, that is given the name, the domain of the relation. Right. And I'll do another video on domain and range separately. And then the other set, I'll put another box over on this side. And then inside this box, the elements that are the numbers that are in the second coordinate positions. And there's no need to repeat stuff, right? So like 3 is in the second set, according to that first ordered pair. 3 is a number in the second set. A little dot next to it again represent. I'm going to point my arrows to the dots. The second order pair 4, the number 4 is in the second set, is a second coordinate. And then the third order pair, I've got 4 again, so there's no need to write it again. Right? No need to write repeats. I'll write that off to the side. So no need to repeat any values. Okay, because I said here 4 was in the second set. There's no reason to write another 4 because I've already got 4 in that set. Okay. And then the last ordered pair, the number 13, indicates that the number 13 is in the second set. Okay, and this second set, with all the numbers, all the second coordinates, is given another special name that's called the range. Now in other books they might call it the target, and there's actually a difference between the target and the range, but like I said in the beginning of this video, this is more for an intermediate algebra course. You want more detail, this difference between target and range, maybe look for videos in discrete mathematics. Alright, so for our intermediate algebra purposes, or just basically algebra purposes, this second set with all the second coordinates of the ordered pairs in there is called the range. And then if I have an ordered pair, there should be an arrow to indicate that there is a relationship between those elements. All right, so I have the ordered pair 1 comma 3. That means 1 from the first set corresponds to 3 from the second set. Now you don't need a ruler for this, but that's why I put the dots there, and make it easier for me. So 1 from the first set corresponds to 3 from the second set, little arrowhead there, and there we go. There's the relationship 1 to 3. 5 is related to 4. 5 corresponds to 4. 5 from the first set corresponds to 4 from the second set, or you could say 4 depends on 5. Whatever, but so I've got 5 from the first set, which is this dot here next to the 5, corresponding to 4 from the second set, that dot there, and there's our arrow, little arrowhead at the end, right, to indicate that this relates to that, this corresponds to that. Great. The next ordered pair, we have 8 corresponds to 4. So 8 from the first set to 4 from the second set. So again, 8 here. And that corresponds to that same 4, right? Again, no need to repeat anything. It's already in there. So 8 from the first set corresponds to 4 from the second set. Little arrowhead, and wonderful. And then finally, the only other ordered pair we haven't touched on is this 10, 13. 10 from the first set corresponds to 13 from the second set. So there's the dot on the left there for 10, and then for 13 in the range in the second set, and voila, right, little arrow. There you go. There's our map, right, or a mapping. And this mapping shows me the same relationships, means exactly the same thing as this set of ordered pairs, right? They mean the same thing. They describe the same relationship between these sets of numbers, the 1, 5, 8, 10, and the 3, 4, and 13. All right, great. And that's all I have to show you today. Just a quick couple representations of relations and understanding the relationships, how to represent in some ways the relationships between elements in one set and the elements in another set. And yes, and sure, there are plenty of other examples you could check out there. Maybe search for other videos, look in your books, what have you. All right. So as I like to say at the end of these, try your best, do the best you can to try to understand or get material ahead of time before you go looking for help. Because I find that it tends to stick with people better. People tend to remember things more strongly when they've taken the time and put in the effort, the blood, sweat, and tears to get it on their own. And they feel more proud of it as well. So read your material. Read the author's examples. Perhaps even try to work out the solutions to an example before you see how the author did it. See if you can learn from any mistakes there. Practice exercises, practice problems, look up answers to check yourself if they're provided. And don't just give up after the first attempt. Don't get so easily frustrated. If after several attempts at a problem, you're still not getting it, perhaps try another read through of the material, maybe even a third one. Because maybe that second or third read through, you'll see something, or something will click that you didn't see or that didn't click before on the first read through, and then go back and try the problems again. But if after that, if after several read throughs of the material, several attempts at understanding it, several attempts at problems, you're still not getting it, well then it is not a sign of weakness whatsoever to go out looking for help, to go ask for help. That is what other people are there for. So ask a teacher, a tutor, a friend, someone in the class who knows the material well, that is willing to help. Look for supplemental materials online. Look for videos on the subject, maybe such as this one, or I assure you plenty of better ones are out there, and they are there for you to find, and you can find them very easily. Just keep at it though, right? Just don't give up. Stay persistent. Keep practicing, keep at it, and also try to have a positive attitude. If you go into something thinking you're going to hate it or saying you've always hated it, well, you're probably going to continue to hate it, and it'll just make learning it that much harder, that much more difficult. If you just try to have an open mind, try to go into it with a positive attitude, thinking I might learn something from this, I might take something away from this, I might actually have fun with this, then it's amazing the difference that could make. So keep practicing, stay persistent, stay positive, and thank you very much for watching.